I really love Five Nights at Freddy's. It has animatronics.
She is such a bad bitch though.
It has books.
The first night is never usually that bad in any of the games, so I'll play through.
And most importantly of them all, it has gameplay. And I am gonna make a fun game. But I'm not gonna be using Clickteam. I'll be writing this game from scratch, and I'm gonna be using C and Vulkan. To start things off, I already created a build system and I even checked that it works. And I also made a basic code to open a window. Also, the game is currently going to be named VK FNAF, simply because I still don't have a name for this game. Anyways, now we can dive into rendering our first triangle. So I began in initializing Vulkan and starting to rendering our first triangle, and god damn it, it took me a lot of hours just to get the boilerplate done, because all of my code bases that I've done in Vulkan are in C++, and this is using C, so I've had to write everything from scratch entirely. God damn it, it took so long. But anyways, we finally got our trusty triangle, and god damn it, it looks beautiful. And now we can start working on the real shit. So yeah. Before we begin, I wanna clear some stuff out. I haven't modeled the entire map / characters of the game yet, because I wanna model the game as I code, so I will have the flexibility of iterating over the gameplay. Because I want the office gameplay itself to be really fun and well designed above all, so I think it is much better to go in an iterative direction rather than being set on everything from the start. Now, I already started modeling the layout of the map. Now this is then going to be the final layout, because obviously I'm probably going to change it for the sake of improving the gameplay, but this can be used as a starter layout and /all for debug renders too, and later on I could add some detail into the map here and there as well. Also, one more thing before we start making the game, here is my proposition. At first I thought I could get away with rendering everything directly to the swap chain on NDC space, to save on needing to make buffers and descriptors, and I still think I can get away with doing that for the office alone, but attempting to layer sprites accurately on top of the office while doing it in NDC space is going to be a nightmare. So instead I think I'm going to be taking a different approach. I am going to render the office and in general the game, excluding the in-game UI, onto an off-screen frame buffer, and then render that on the swap chain using a full screen quad, and then render the in-game UI on top of it. I think this approach is going to be beneficial, especially for the office, where the base renders for the office are going to be made using an equirectangular projection, so that we can use a cylinder effect like post-process effect to turn the section of the sprite that we are zoomed in for the horizontal scrolling into a 3D-like perspective look, giving us a 3D-like look of the office. And just like that, I started working on implementing texture rendering into the renderer. Now, one thing I gotta say is that I am using a library called VMA to help me with allocating memory. It's just a simple allocator helper. I'm still doing a lot of the work behind the scenes. And also, since again, I am all of my previous code bases are in C++, then I needed to rewrite the loading of the textures again, and it took me quite a while, but I did it, and now we can finally see textures. So now I can finally go ahead and add the texture of the office. And exactly like that, we have the office rendering, and I even done a little bit of code to make the office zoomed in and scroll horizontally when I press the keyboard. So yeah, now we can move on to rendering to the off-screen buffer. So I created an off-screen color buffer, an off-screen render pass, and an off-screen frame buffer, and at first I checked to make sure that the swap chain itself still renders, and after that I went on to adding the off-screen buffer onto the swap chain, and there we go. So now we can turn it into a 3D like view. So here I tried rendering the office with a warping effect, and I thought I was cooking, but little did I know that the implementation would be extreme demon difficulty. So I tried a few things, and here are the stuff I came out with. What the hell is this? Oh my god. Oh no, no, get it away from me! Eventually I ended up giving up, and I asked Gemini to give me an implementation for the warping effect. And after tinkering with it a little bit, I managed to get it working, and voila, I gotta say, the clunker absolutely cooked with this one. I even went ahead and changed how the scrolling works. Now I can scroll the office with the mouse cursor. Now we can finally start working on layering sprites over. Okay, so as it turns out, I forgot to record it somehow, but generally speaking, what I have done is I have modeled a fan in Blender, and I've also animated it. I then went ahead and rendered every frame of the animation of the fan spinning, and then using GIMP I connected them all together into a texture atlas for the fan. I then wrote a shader for specifically the texture atlases, and I also rewrote how loading the textures is gonna work, with an ID for each texture and a number for the maximum amount of textures. And after tinkering with the position and scale of the fan sprite for quite a while, we finally have our fan rendering correctly on top of the office, just as expected. And just like that, we can render sprites on top of the office. Just for the context, here's how it looks without the warping effect. I hope you can see what I mean when I'm saying that rendering to an off-screen frame buffer is beneficial. That means we can layer sprites on top of the office in 2D space, and as a post-process effect we can have the full-screen renderer apply the warping effect. So now I began working on the in-game UI system, and basically what we are doing is we are rendering the in-game UI directly onto the swap chain, because we don't need the warping effect of the off-screen frame buffer. And because of that, I basically split the rendering of the swap chain into two functions, and between those I render the in-game UI. And just like that, we have in-game UI rendering properly. So now we can also implement buttons, text rendering, hoverables, and more UI elements that are gonna be beneficial for this game. I also implemented text rendering, and I didn't record it for a reason. It was super difficult to implement, especially because my math was all over the place at the beginning, and also because the library was quite weird to deal with and how it integrated with CMake. But yeah, I did it, and I also ended up adding text for the timer of the in-game hours. So yeah. And after that, I very quickly implemented hoverable elements and also UI buttons, and also fixed some stuff with the projection matrices. I made them much more efficient than how I did them before, so now they work much better. And yeah, that's pretty much whatever I wanted to do for the in-game UI for the time being. From here on out, there isn't really anything of importance to talk about. Everything in the game engine department was already done at this point. So from here on out, everything that was left to do was just make the game and make more renders, just design the UI and code the animatronic logic, which is gonna be super simple, that too. So yeah, so now I'm not gonna have long segments for each thing. Instead, I'm going to do short segments showcasing a compilation of everything I did in a short matter of time. So I've expanded the in-game UI a little bit, and I added the monitor flipping and the monitor itself, as well as 4 cameras, which are gonna be for the time being. So here I have added the doors, and also the buttons for the doors are UI buttons, and that's because they are simply the hitboxes of the door buttons, not the sprites in the office render. Now, ignore the shading differences between the doors in the office. It's just that in the Blender file I lost the light source, so I made a new one. But it doesn't matter. It's just placeholder images anyways. So yeah. So now that we have the doors and basic cameras working, we can start working on the first animatronic. Now, the animatronic is going to be super linear for the moment, just to get things done. It's just gonna move to the office and be stopped by the door or jump scare the player, and that's it. And basically, after a jump scare happens, the game just freezes. I don't think I'm gonna have any menu or anything. The same goes for the winning condition, whether the game reaches 6 AM too. So yeah. And just like that, I finally have Freddy as the debug animatronic. Now his AI is set to 20 in this video specifically, and basically he just goes from the top camera to the bottom camera and then either stopped by the middle door or jump scares the player. And I've also added sound effects on top of that too. So yeah. To conclude things off, this is obviously not the final game or anything, it's just a simple pre-alpha engine demo. I wanted to focus on the engine portion of the game first, and phew, these last few days have been huge, and now honestly I'm exhausted. Working on the gameplay from here on means obviously working more on the 3D models of the map and working on characters too. So I'm going to do it in my free time here and there and take my time with it. After all, this is something I'm doing for fun. But I do aim for the end result to be a polished, high quality Five Nights at Freddy's Fangame that is made entirely from scratch using C and Vulkan. And yeah, eventually I'll get there. No pressure though. One more thing, this game is also going to be open source on GitHub too, with a guide on compiling directly from the source code as well as downloadable builds on each IO and the gamejolt for both Windows and Linux. Just remember, this is super bare bones at the moment, as it is just an engine demo. I'm obviously going to release more builds of this game as I add more characters and game mechanics and improve the visuals more, so yeah, there is that. But all in all, this is it for now. If you made it this far, thank you all so much for watching this video, and I hope you enjoyed it. I hope you enjoyed this video despite my constant stuttering during the coding parts due to the lack of scripting in this part specifically. And I will see you all in the next video. Bye bye!